Hello, this video is on section 3.1, which is the very beginning of chapter 3, and it's titled Solving Systems Using Tables and Graphs. And I'm more concerned about the graph as opposed to the table. There may be one or two problems that we go over with this table, but the main thing that we're going to be focusing on is how to solve it using graphs. And the learning target is to solve linear systems using a graph or a table, again, more importantly focused on the graphing portion. So a system of equations is any set of equations that has two or more equations within it. So if you have, say, y equals 2x plus 1 and y equals, I don't know, negative 4x. This entire thing right here is a system. Now each of these individual lines is an equation, but if you have two or more of these, that is a system of equations. And when we try to solve these systems, that means we're finding a value or a set of values that can replace our variables, or the y's and the x's within our system, in order to make both of the statements true. Now, in this case, we're only going to be dealing with two, so when I say all, I'm usually talking about only two equations inside that system. So if you think of it graphically, and you have your xy coordinates, and let's say we want to pick these two graphs. So we have y-intercept of plus 1, and graph of 2x is going to have a slope that looks like that. And then if I'm choosing a different color, let's make this in the kind of green that I had earlier. The negative 4x has a negative slope, and it's even sharper, but it's in the negative direction. When you are solving this system of equations, graphically, the solution is the set of points where these intersect on the graph, and I'm going to teach you how to do that in the graphing calculator first, before I go on to do it algebraically in the later sections. The next thing I want to talk about is the different types of solutions you may come across. Now, the first one is a consistent system, and that means you have at least one solution. It could be 1, 2, 3, 4, all the way up to infinity, but you have at least one. There's always going to be a solution in a consistent system. With an inconsistent system, that is the opposite of consistent, and that means you have no solutions. The two different types of consistent systems, so this splits into independent and dependent. Independent means you have exactly one solution, and dependent means you have infinitely many solutions. So the way you can see it graphically is that a consistent independent solution is exactly like the first example that I had put up here, where you have the two lines intersecting at one point and one point only, and it's just one solution. Consistent dependent means the lines are on top of each other, and that they have the exact same slope, exact same y-intercept, and infinitely many points are being intersected between the two lines. It has infinitely many solutions. Then the last one is this green one, inconsistent, no solutions. They are parallel lines, which means the exact same slope, but they have different y-intercepts, so they will never ever intersect, or there will never be a point where the two systems are equal to each other. Now, again, in the graphing calculator, there is a way to do this, but I will show you in class. But you will know how to classify some of these systems, and for some of these, it will help you better come across your answer, whether you're looking for one, infinitely many, or no solutions, because sometimes it may cut your work down 4 or 5 steps before you even need to get down to the answer. All right, but that's it. Get ready to learn how to do it on the calculator in class. All right, thank you.